This presentation focuses on predicting accident severity based on driver behavior and environmental factors. Let's begin with the key topic covered: problem and data, methodology, analysis, results and discussion, consideration. Let's move on the problem statement. Traffic accident case serious safety and economically concerns. Understanding key factors can help prevent severe outcomes. This study used machine learning to predict accident severity low, moderate, or high based on driver behavior and environmental conditions. I hand over to Deshani. Continue from here by elaborating on the problem description. Thank you.
Thank you, Mutuni. Now let's move on the problem description. We aim to analyze how driver behaviors and environmental factors contribute to traffic accidents. Driver-related factors include alcohol consumption, experience, and age, while environmental factors cover weather, road conditions, lighting, and traffic density. Traditional methods rely on historical reports, but machine learning offers a more scalable and accurate approach. Our study focuses on how do environmental and driver-related factors influences accident. Can machine learning predict accident outcomes, and which model performs best? Now let's look at the dataset we are using for this study. Our dataset includes both categorical and numerical data. Environmental factors consist of weather, road type, road conditions, lighting, and time of the day, along with traffic density and speed limit. Driver behavior data includes alcohol consumption, driver age, experience, and number of vehicles. This dataset helps us build machine learning models to predict accident risk. Now I would like to hand over to Tavisha to continue with the methodology part.
Thank you, Deshani. Let's talk about the methodology of our project. In the data pre-processing phase, first we check for the missing data and apply appropriate imputational techniques. Numerical values are filled using the median to reduce the effect of outliers. Then the categorical values are filled using the mod to maintain the consistency in the data set. And in the handling duplicates, secondly, we handling all the duplicates. First, we get a count of all the duplicates and we drop all the duplicates. Lastly, we encode all the categorical variables by using one hot encoder. Then in the data visualization pane, we plot distribution of numerical columns, all the numerical columns. And also in this code, you can see we include the vertical lines for mean and median in each variable. In data visualization pane, first we visualize a distribution of all the numerical values. In this code, you can see we include the vertical lines for mean and median. In each distribution plot, you can see the mean and median line. The first plot is for driver experience. The second one is for driver age. And third plot is for distribution of speed limit. The fourth plot is for distribution of number of vehicles. And this is the plot for identify the traffic density distribution. And this displays the frequency of different traffic density levels with distinct colors, and mean and median indicators also applied in this plot as well. And this is the pie chart for the displaying the distribution of driver alcohol consumption. We input a color coded for drunk and non-drunk drivers to identify clearly. And also we plot all the categorical features to show the distribution of all the categorical features. In here, you can see the first plot is for road light condition, and second one shows the count of various road conditions. The third plot is showing illustrate the distribution of different types of vehicle. The fourth plot represent the count of accident based on severity levels. And the fifth plot in the categorical features displays the distribution across the different times of the day. And also the fifth plot is showing the count of different road types in the dataset. And as the last one, it shows the highlight the frequency of various weather conditions in the last plot. Finally, with using Spearman correlation, we calculate the correlation between all the numerical variables. Here you can see the correlation values, and also we plot a heat map to show the correlation clearly. And next, Netulya will explain the model section phase. Thank you.
Thank you, Tavisha. I will now tell about model selection and training. In our project, we developed a machine learning model to predict accident severity based on environmental and driver-related factors. First, we separated the dataset into two categories. Environmental features like weather, road type, and traffic density, and driver-related features like vehicle type, driver's type, driver's age, and experience. After separating the features, we applied one hot encoding to convert categorical variables into numerical values. Then we split the dataset into training and testing sets with 80% used for training and 20% for testing. This process ensures that our models learn from historical data while being evaluated on unseen data to assess performance. Our model training ML algorithms. We use 3 algorithms to complete this project. To predict accident severity, we train 3 different machine learning models: logistic regression, random forest classifier, and decision tree classifier. Each model was trained separately on both environmental and driver-related factors. Logistic regression helps in understanding relationships between variables. Random forest is used for capturing complex patterns, and decision trees provided easy interpretability. By using multiple models, we can compare their performance and choose the best one for predicting accident severity. Model evaluation. After training the models, we evaluated their performance using key metrics: accuracy, precision, recall, and F1 score. Accuracy tells us how often the model predicts correctly, while precision and recall help in understanding how well the model distinguishes between different severity levels. The F1 scores provide a balance between precision and recall. These matrices allows us to determine which model is reliable, which is for predicting accident severity, ensuring that we choose the best performing one. Finally, the results and best models. Based on our evaluation, the best performing model was logistic regression. It achieved an accuracy of 66.1 for environmental factors and 67.78 for driver behaviors. This means that driver behaviors were slightly more predictive of accident severity than environmental factors. While this accuracy is reasonable, there is room for improvement. Future enhancements could include collecting more data, improving feature selection, or testing advanced models like deep learning. In summary, our model provides valuable insights into accident prediction and can be used to improve road safety policies. Thank you.
Thank you, Nitulia. This slide details the limitations of our current model and the corresponding improvements we plan to implement. We face challenges with limited data features, class imbalance in predicting severe accidents, and potential dataset biases. Future work will focus on expanding our data, exploring deep learning, implementing real-time prediction, and adding geospatial analysis. In conclusion, our study developed a machine learning model for accident severity prediction with logistic regression performing best, aiming for real-time analysis and smart transportation. These are our team members. Thank you for your attention. Let's take a look at the demo. I will now hand it over to Tavisha to explain what's happening.
Welcome to the demonstration part of our video. This is the code file we use to implement our project. First, we import all the boundary packages. Then we import our dataset. So this is the dataset we used in the project. So we describe them, and in the data pre-processing part, first we handle missing values. First we fill numerical values with their median, and then we fill categorical variable data with their mods. Then we handle duplicates. First we count them, we found 18, and we drop them. In the visualizations pane, we visualize all the categorical and numerical data with including vertical lines for mean and median. Here you can see the numerical variables here, distribution of numerical variables, and here more as well, traffic density distribution, and the driver alcohol consumption distribution. And we also plot a distribution of categorical features as well. You can see all the plots here. And finally, we calculate the correlation between all the numerical values and plot a heat map to identify them clearly. The last phase is machine learning model implementation. We first we separate our features as environmental features and driver features. Our targeted variable is accident severity. Then we split our data as 80% of data as training data and 20% of data set to the testing data. We implement 3 machine learning models. In each, we calculate the accuracy and implement a classification report separately. So our first machine learning model is logistic regression. It shows accuracy rate of 66 for the environmental features and 67% for the driver features. And our second machine learning model is random forest classifier. It shows 61% accuracy rate for the environmental features and 50% of accuracy rate for the driver features. Then the last one is decision tree classifier, and it shows 50% of accuracy rate for the environmental features and 49% of accuracy rate for the driver features. Among these three, we choose the logistic regression machine learning model as the most suitable one because it shows the highest accuracy rate for the both environmental and driver features. Thank you.